I'll introduce myself. It seems like there's a lot of people who are new to this workshop series. So this is our group, the CCT data science team. We teach workshops at least once a month on a variety of subjects that are generally aimed at things that are practical, you might not see in class, but will make you more effective in your computing and research. So I'm David LeBauer. I run the group, and I'm a scientist and experience using things like APIs and programming. And so when I first learned about APIs, there were a lot of things that confused me. I think the first time I heard the term, it was just so foreign to me. But now that I've used them, developed tools to use them, I've got a better handle on it, and I wanted to share that with people just because, there was kind of this long learning curve for me. So hopefully I can shorten that just a little bit by showing you a little bit of, getting into APIs. Excuse me. So with that, we'll get started. I also wanted to point out that I'm going to be giving you a talk about APIs and how to use them with a very much kind of digging in and looking at how they work and what they are. It does not, this is not from a computer science or a theoretical background. This is not what a programmer who's developing APIs would need to know. This is more aimed really specifically at scientists who see APIs and all the data that they provide and want to be able to use them. So here's an overview of what we'll be doing today. The goal is to demystify APIs. I'll discuss what is an API, why are they important, and how you can use one. First, we're going to dive in, and after we dive in, I'll step back a little bit and kind of show you what just happened. So having said that, just to give a very high level overview of where APIs are. So we haven't dove in yet. This is kind of just an API, a very brief overview of where they fit into the entire system, perspective of a scientist. So a data provider may have a server with a database or multiple databases or multiple sources of data, and they want to make that accessible to people out in the real world, scientists, for example. It's very difficult to provide access directly to a database for a number of reasons. First of all, there's security. So if you can access a database, then that gets you really close to how it works. And there's a lot of attacks, a lot of malicious attacks through databases. You may have heard of SQL injection attacks. That's what they are. So, first of all, an API is a way of protecting those databases, but at the same time, it's also a way of providing a clearly defined way of interacting with those databases. So you can, so that people get there and know what to expect. So databases in general can have a variety of structures. So if you wanted to get data from somebody's database, you wouldn't necessarily know, how it's structured, where to look, what tables go with which tables, or how different pieces are connected. So the API provides a unified interface as well as this kind of layer of protection. The other nice thing from that perspective is that once an API is defined, and we'll look at what I mean by an API being defined, but like what that data looks like when it's coming out, when I go and collect it. It frees up the people on the back end who are in this server area. It allows them to do whatever they want with the underlying databases. They can change the way the data is stored for a variety of reasons that don't have to do with how you're getting data from the database. And even after if you restructure the database underneath it, you can still run some code that will reformat the data so that it is consistent with that API, with the previous API. So you can change the underlying data without having to change the API itself. And then there's the client. So an API is effectively this layer in between the server, the people who are providing the data, or the machines that are providing the data, and the clients. And the clients you can think of as yourself if you're programming and accessing data, but primarily the API, it's written for another computer. So it's really a way in which computers talk to one another. By contrast, you may have heard of a graphical user interface or a web browser. This little icon down here indicates a web browser. So a web browser is a way in which you can interact with the data by pointing and clicking. And so that's a very human-friendly way of interacting. But that web browser on the back end is interacting with an API. So let's kind of, this is where we get to dive in and just investigate how the web works. So this is the as I was saying, it's made for humans, and it's pointy and clicky. And we're going to look at this GBIF database. One of the reasons that I chose the GBIF database is because it's very stable. It's a great example for teaching. The wide world will probably be a lot more messy than this example, but we'll go ahead and dive right in. So the first thing that we can do, and this is, you're welcome to follow along, but you don't have to. I'm gonna kind of do this in real time. I've left myself, hopefully, well, a lot of screenshots in case what I'm doing doesn't work, but also links. So if we go to www.gbif.org, you can go here, and this is what I mean by pointing and click. I come here, use the search bar, and I might look for a cougar with a name of Puma, Concolor, search for that. And then I wait a little bit. Now it's coming back with all these different responses. So there's a whole bunch of records that went somewhere into a database and found a whole bunch of different records, different types of records. So there's like this high level species description, there's a bunch of data sets, there's occurrence, there's checklists, etc. And then there's a whole bunch of species and subspecies that you can dig through. Look up here, there's also different types of queries, so we could just look at the species. And now we have this list of a whole bunch of different species and subspecies. You can see there's all these other options over here. You can limit the search, etc. So this is how I, as a human, might do this. But now we want to look at how a computer might do this. So we'll look under the hood. In order to look under the hood of your browser, there's this thing called Developers Tools, which you can access with Control, Shift, and I, or you can go over here and go down to More Tools, and then click on Developer Tools. And then you'll have this thing pop up over here, but I don't want it on there. I want it over here. So let's do that again. More tools, look at the developer tools. Now, open this up a little bit so we can see what's happening. I'm going to stop recording, clear everything. And we're interested in this network tab. I just pulled that over here, so it's handy. If you look here, there's like, you can get a whole bunch of different tabs. So if you don't see the network tab, you might have to come in here. Look at the network tab, and I'm not going to record yet. I'm going to go back. I'm going to redo what I already did. And I'm going to look for that again. We're just going to record this and watch what's happening on the back end. search for this Puma again. Something happened. There we go. And the search just happened. Now there's all this stuff that happened back here. There's a whole set of different interactions that our browser did with the database. But if we look right here, the first thing that it did was it sent this request. It said, and search for Puma concolor. So it has translated what I just typed into here and here. And it says that the request method is get. So it's saying, go and get that stuff. And then the next thing that it did, if we look down, if we just look for all the search things, it pulled back a whole bunch of different, it pulled back some stuff to the layout, how the web page looks itself, but it also pulled down a whole number of records. Let's see what it pulled down. Where did these things go? Oh, here we go. So search taxon key equals that. Search down here, data set key. So it went back, it went and it said, well, let's go search for Puma, and then let's pull back each of these records. So it pulled back a whole bunch of records, and now it's displaying them using these different calls. So it's getting all this information and putting it onto the page. So that's what we just did. I was showing you more tools, developers' tools. Excuse me. Just walking through what we just did. So you can see that this URL up here is the same thing that was in this URL down here. So on the back end is reflecting what's happening in the front end. Okay, so what's happening here is that the web page made a request through the API, queried some information from the database, and brought it back and displayed it for you. But what's missing from that user interface, from the perspective of a data user, is having some analysis-ready data. So I have this little asterisk down in the beginning, in the bottom, because there are plenty of websites that have really awesome data, including data presented in tables and documents, etc., that don't have a nice API, don't have a nice way to go and get it. So there's a whole universe and ecosystem of tools that scrape data from the web. And you can program that, but the easier way is if there's a clearly defined API. And then you can access the data. You know, I have a couple icons over here. You can get into Python, into R, into Excel, or your favorite programming language, or you can just download a text file and start to fiddle with that and read through it, as we'll do in a few steps. So that brings me to the next step, excuse me, which is getting data for analyses. And this is really where an API is useful for scientists and data analysts, because the API, it's made for machines or for your programming language. So it's programmable, you can automate it. And we're gonna continue with this example of GBIF. And what I'm gonna do is I'm gonna walk through the steps to figure out, you know, how could I do the equivalent of what was just presented on that website, but using my favorite programming tool. And because there's really great tools that we'll walk through, it's going to be pretty easy, you know, once we understand what the API works. But the first step is reading the documentation, which is kind of tells you how to talk to this. Oh, I forgot that I can't click these things. So I'll have to navigate naturally. Okay, so we're going to get data directly from the API. So if we go here let's see, tools, and find it, access, use, drive data sets. I apologize, I hadn't, well, I just planned on clicking this link, so I'm just going to go ahead and click the link, make life easier. So gbif.org developer summary. Let's see, there must be under tools. Yeah. Okay. Usually there's a nice way to a nice API if it's provided. But as I mentioned, it's not, so we just go to the developer summary. Okay, so this is the API summary. You can see it's got some of the same things when we were searching earlier. It's got some of the same tags, including species. Down here, it's going to start telling you about the API and how you can use it. And we're interested in species. What this is going to do, it's going to say, we have this API here, the API right here. And so there's an API at this URL, and that's where it points to the documentation. And then with that API, there's what are called endpoints. So you come down here and you can see all in which you can query data. And we're going to try a fairly simple one, which is the API usage equivalent of what we did earlier when we looked for the species of the puma concolor. And so we have all these endpoints, and it describes what happens, and then it tells you what the parameters are. And if you click one of these parameters, it'll tell you what types of information you can use type of in that parameter. So we could just look here and find out what are all the 2-letter codes for our favorite place, HY. So that's how you can start to interpret this documentation. But we're just going to use the name parameter and construct a URL. Let's see. We're going to search for that name. Let's continue. And we're going to construct a URL. Well, this is what we did earlier, was we saw how pointing and clicking, we put together this set of this query. And then with apologies, that was the wrong, this is the wrong, this says butterfly, but we're actually looking for the puma. Anyhow, so we can take that URL, we construct it. This is what we saw is the host where the API lives. And then this is what's called the endpoint. And then we can put together our query starting here. All right. So I'm gonna get these developer tools off of my go. There we go. Okay, so we can put together the API like this. So, or we can read it here. We can say, okay, so we're going to have species, and we're going to have a query parameter called name, and we are going to come up here and we'll say api.gbif.org/v1. You can see it's all the way already in my history, species, and then the question mark says we're going to start our query now. So we're going to hit this endpoint called species, and we're going to find this name called puma concolor. And very quickly, I wanted to ask everybody just watch what happens with this space right here, because computers don't really like spaces. And you'll see that the space is turned into this %20, and all that does is it represents a space in characters in a way that the computer is happy with. That way, the concolor doesn't kind of float off into space and get disconnected from the query. That's all that happened with that %20, is that the computer understands it as a space. And you see this now you can see why this is not the primary way in which humans interact with this database, because it's much easier, much nicer to point and click through the pictures, and it's got the range maps and all that on the website. But this is the API, and there's one thing that we can do that'll make this data a little bit easier to read, and this is the you can get an extension. So this is one that I've gotten called the JSON formatter, and what it's just going to very quickly, kind of take all of that text and structure it nicely, so at least it's easier to read and navigate through. So what we have here, I'll talk a little bit more later about what offset and limit are. That's how you get through, this says it's not the end of records. So we've got, 20 records here, maybe 2,000. And if we want to get through all 2,000, then we have to either specifically request them, or we have to get multiple pages. So this is the high level kind of metadata section. And then these are the results. This is the data that we're actually interested in. And you'll see there's a lot of numbers in here that just aren't really that useful for humans. But if you were programming this and you wanted to do something automatically, a lot of those other and let's go look back here. If you look at this documentation, you'll have once you start having longer things, you have to put these numbers in there. So you have this int or the short name. So these are all things that you can find once you're querying the data set, and you can send it back and get information more specifically about, or you can get more specific in, for example, about this species. So these are all ways in which you can query additional information from the database, but there's still useful information to the scientists here that you can get. And you can kind of go through, we can look at all the 24 records. So this is another thing that's nice up here, is we can kind of click through, and etc. So that's a useful tool I wanted to make sure to show, to clean it up. So the JSON matter. Another thing, just to kind of revisit another way in which APIs are used, is if you went to Google and you wanted to find a JSON formatter plugin, then effectively what happens up here, there's a whole bunch of stuff going on. But the important part is that we've done exactly the same thing just with Google's backend database, which is we've put together the URL, the endpoint, which is search, and then a query, which is for this JSON formatter plugin. So this type of using URLs to construct queries is fairly common, I'd say almost ubiquitous across the world of interacting with computers. Okay, so, well, how did I do that? It's the case where I promised to dive in and then step back and say what happened, but so I did that, and now, you go to the API summary and you can dig in there and find out how it actually works. This is exactly what I just showed. And then just to reiterate the way that the API request is structured, I forgot to mention, so this is a protocol. HTTP and HTTPS are similar, except that the S is secure. This is the domain of the where the API lives. Well, the API lives at this version 1. So this is versioned. The API itself is versioned. The way that it works and the data that it returns are versioned as version 1, but the data, the underlying data, is not versioned as version 1. The underlying data is can change underneath your feet, which is one of the limitations of APIs. So if you're searching for weather data, for example, every day you can get a new weather forecast, or you can find out what the current weather is, but the structure remains the same. It's just new data are added. And so this is the endpoint that we looked at, and then this is the query. You can put together much more complicated queries. As you saw, many of the endpoints have multiple parameters. And we'll look at one later when we look at the limits, when we want to page a data set. And then what was responded, I mean, what we got out of that, again, was metadata. This tells you there's no standard, but this is just their information. They're providing you information about this response, and then the results, you have one one at a time. And this is a relatively simple way of structuring data. So each result has what are called keys, even though this one is actually named key, but these are keys and values. So each one of these is called a key. Each one of these is a value. All the values are just one vectors of length 1. So they can easily collapse into a table. You see, I'll get back to this in a sec. I'll get back to the questions in a minute. So just to get back to what is this JSON stuff anyhow, because if you're like me, when I started developing APIs, I was working with computer programmers, and I said, well, can't I just have a table? Like, why can't I just have a table? Why can't, what I really want is a table. I want a CSV. Like, if I have a CSV, then I can, how to analyze that. I can open it in Excel. I can read it in as a table in R or Python. The reason that JSON, well, one of the reasons that JSON is so ubiquitously used is that it can support a very complex structure to the data. And I've got an example, another example later where it's more highly nested. But for example, instead of having just phylum chordata, you could have, a whole other element, like another bracket with a whole other set of things. And you can have kind of arbitrarily high level of nesting, or you could have a vector of elements. You can have multiple numbers here. And so what this means is that you can take a very complex, data structure, as data is often stored in very, complex hierarchies, and you can represent that in JSON. And then a computer scientist may ask, well, JSON's great and all, but why not XML? And I'll just briefly say that you will find APIs that return data as XML. It is also supports a similarly complex structure, but in addition to supporting a complex structure, it supports what are called schemas, which can define what each of these things can be. It's even more complex. So you can have much more, you can describe the data much more specifically. And so there's a trade-off between ease of use and the capacity to handle complex data. So this has become more or less the convention. And effectively, there was a number of times when I asked, like, well, why can't I have a table? Why can't I just connect directly to the database? And ultimately, without getting into the underlying computer science of it, it's just, this is the way that things are done. And once you get used to it, it's becomes more usable. Okay. Fortunately, as I mentioned in that example, you can get a table by taking each of those results and kind of laying them out into rows. So each of these results can be turned just into rows. And there are a number of clients from common programming languages, R, Python, etc., that will do this automatically. In R, one that I commonly use is this one called JSON-Lite, and it has a function called from JSON. And there's a number of packages that have this from JSON, and you can just this URL directly in there, and it'll read it in. And you'll see it reads it in as a list, where each element of the JSON response becomes an element of the list, but the results are collapsed into a table. And that's because this library takes the liberty of assuming that this is how you want the data to be returned. Now, if you do this with a very complex data set, then you may end up with complex things. So you may have a table, and within that table, there's another table or another list or multiple elements. And so it takes some fiddling around in order to get the data in an analyzable form. And that's really all I can say at this point. It's, there's definitely some trial and error to it, especially with more complex data sets. But this right here is a data frame that can be moved in your analysis. And so back to why not CSV and some of the more complicated structures that are allowed. So this is just an example of an API that I helped to develop, which is called the Breeders API. And the Breeders API is a definition of what the API should look like. And a lot of people have taken their own bespoke databases and mapped them to this particular API, which is great because this is kind of the first step toward data interoperable. But still, you can see it's much more complex. So in this case, if we were to think about having a database with multiple tables, then you say, well, you've got this location, and you can have the name of that location in one field, but there's other information that you wouldn't necessarily want to store. It would be complex to line it up into a table. You may have multiple locations, multiple seasons within your response, and so to structure it like this because it reflects how the data is stored on the back end. And ultimately, this means that less information is being transmitted over the internet because you don't have to have all the information in every single row. So this is just to show you some of the more complex structures that JSON allows. Okay, I also wanted to talk about another important part of what you might end up with when you're looking at APIs, which is pagination. So just like you could have back in the day when people wrote on scrolls, you can just like keep on adding new pieces of parchment and continue to write and roll it up. But finally, when we settled more on book style, the content was divided up into multiple pages. And similarly, a lot of times when you make a request, there can be, there could be 300,000 records, a gigabyte of data to come across. And the data provider doesn't want everybody to just automatically be pulling across a gigabyte of data if what they really want to do is just look at take a look at the data itself, see how it's structured, see if it could be useful. And so it's very common to see additional query parameters that will either they'll be paired. It'll be like the offset and the limit. So the offset refers to like what page to start on. So you could say offset is 10, and that means that you'll start on the 10th page, and then your limit will be 100, and that's like how many records to bring on that page. I guess that's more page and page size. Offset would be how many records to start. So you would say, so you could start with the default and not have offset, or offset 0 and limit 100. Pull back those 100 records. And then you say offset 101, limit equals 100, and you pull back the next 100 records. Or that should have been offset 100 and limit equals 100, pull back the next 100 records. Then offset equals 200, limit equals 100, pull back those. And so you continually pull back all of these. Or if they allow it, you could just say, when the result is returned and it tells you that there's 34,000 records or however many, simply say limit equals that number of records, and you can pull them all back. Page size is another way of doing that. So I didn't want to get too far into that, but just it's such a common pattern from data providers that I wanted to make sure to show you how that works. So, and here's an example of an API that has offsets and limits in them, and how those can be constructed. And you can also see that this is a different way in which to provide a header or metadata. So than the way that GBIF provides theirs. And then instead of saying results, here's the data, and each record is implicitly a result. So I wanted to point out another handy tool. So the first one was that JSON formatter, just to look at the pretty JSON. So the next one is going to be Postman. And Postman is it's a freely available workbench for putting and using APIs. And I just wanted to point out a few of the handy tools within Postman. So you can find Postman at postman.com. I don't mean to promote any particular software, except the ones that I use and am familiar with. So when I open up Postman, this is what it looks like. And I want to start a new query. And we're going to enter the request URL that we were using previously, which, if I remember correctly, was API, it's even here, .gbif.org. And then v1 species. Okay, so what happens if I hit that? It will say, so here we have the offset and we have the limit, and it is just going to return all of the species. Well, not all of them, but 20, but I could ask for all of the species. But here it will return the first 20 species. Here's record 2, 3, 4. But if I wanted to look for, specifically this puma, then I can either continue writing this up here. As soon as I write that question mark, if you notice, this just opened up and it's like, okay, what's my first key and value? So my first key is going to be species. See how that's happening right there, and the value is going to be puma concolor. And now I send that. And
David?
Yeah.
In this case, is key synonymous with parameter?
Yeah. Okay. Let's make sure we got something useful down here. Name key. So this is where we would have to continue. So, ooh, this is a bacteria. Oh no, my query has fallen apart. Let me see if what I messed up. So this hasn't returned what I wanted. I think I just assumed it would. What did we look at earlier? We looked at this species name equals Puma concolor. Needs to be URL. So if I take this and put it in here, I send that. That was correct. Yeah. Definitely need that 20 in there, I think. So one thing that, a key difference here is that I added the protocol. Let's see what happens if that was a space. Send that. Yeah, and so that worked correctly. Anyhow, so back to where I wanted to be. I think that's
David,
what I messed up. Yeah.
oh, sorry, you didn't have the name in the other query. You just did species question and then, yeah.
Thank you. Thank you. That was it. Okay. Okay. So we've returned this. So we've returned this thing. I guess that if I didn't have the name in there, then it just returned all the records again. Okay. So here we go. I got all the records back. Well, I didn't get to the end of records. I'm certain that there's an endpoint I could ask to see if there's more records. I can also say add on another parameter, but I just add it down here. So, and I'll say the limit. I wanted to say the limit equals 100. And you see it added this on with an and. So we're stringing together parameters like that, and I'll send that. And I got to the end of records. I don't have the number of records handy. So how did it know Puma concolor is a value associated with name?
Oh, I think earlier you had species under the key, right? But species is the end.
Oh, yeah.
So now the key is the parameter correctly, and then the value is the name, or is the actual name that we're using. Okay.
Yeah.
Thank you.
Mm-hmm.
So you had to type, when you type that address at the top, you have to type the address, the version, and the endpoint, and then you can feed it the keys and values.
Yeah.
Okay.
And these are separated by ands. And you could continue to do them down here, and it'll put them together nicely with, up here for you. So the next thing that I show, this is handy, but we get about what we had with, we've gotten just about as far as we can do within a browser. You know, we've gotten this JSON pretty formatted. If we wanted to, we can save the response. We can save it to a file. Excuse me, as a JSON file. What you might not have seen is that this just said, you know, it'll save it as response.json. I usually like to save these in my downloads. Okay, so I can save it like that, but before saving it, it just, you know, spit it out into this console, or printed it out. And the next thing that I wanted to show was how you can generate code to do that exact same thing. So let me get back to Postman. Excuse me. So there's this little tiny icon hiding up here, which is, you know, one of the most useful things that I find. In here, let's just go back. Curl. So curl is like, you know, the default, program that works on almost any line. And this shows you how to take this and let's see if I can copy it. Okay, how I can get this to happen on my computer. So if I go to, I'll open up the terminal. I'm gonna open up my terminal. This would work. So this is would work equally on Linux or Windows or Mac. Let me open one that's just a standard Windows, because then I can go to my downloads. Okay, so what I copied and pasted was that. And if I, so I didn't like this, let me see. I can do 20, where it got sad. Sure, it didn't work. So I promise I tested this all out. Why does that not work? Well, let's see what happens if I do it in, I did test it out on Windows. If I do it in on Linux, it works. So this is the equivalent of having opened up the browser the first time. It's not very pretty printed, but this is what we have. This provides the data that we want, except it's not in a file. So if we wanted it to be in a file, so this code snippet just shows us how to generate that, and leaves it up to us to figure out how to put it into a file. There's a few different ways we can get into a file. The easiest, I think, well, we could either use curl's built-in, but if I use that little caret, it's going to take all these words and put it into a file. So I'll call it response to JSON. Now it's downloading that, and I can look at response to .json, and it's the same thing, but now it's inside of this. Now it's inside of a file that I could read in. Or I could pipe it to any other program that I use at the command line. But the other cool thing about this is that no matter what program you use, or for many of the common programs that people like to use, and I'll focus on Python and R because that's what a lot of people, a lot of scientists use. It'll provide you with, a couple options here. There's two different libraries that you could use. Request and HTTR are pretty popular for Python and R, respectively. And it'll give you this code that I can copy, open up my R command, R terminal. I was playing at this earlier, and see, and hit that. Let me just save that. No. Okay, apologies. I would have to learn how to deal with this object of type res. So I'm going to go off script here and say, now what can I do with this class method? Class equals response. Print. Now why? Now it's empty. Maybe.
You have to put the 20% thing in there, or
Yeah,
20?
I think that's what it is. Thank you.
So sometimes it does it for you, and sometimes it does not do it for you.
I would really like to say that running into issues specifically so that I can alert the audience to where things may get messed up. I can't say that, but it is useful. So anyhow, so that's where it works. So here we go. We've got this issue right here where you have to replace this because the computers don't like spaces. And it does the same thing. And now things that will work. Curl hopefully would work. I don't know. I'll just try this one more time, even though I did it just to see. Oh, I did. If it'll work on Windows. That is the same thing. Okay. Didn't like that. It might be because of the quotes, but the point is that there's a lot of useful, powerful tools. Postman, and it kind of helps you make that bridge from having an API that you can explore, look at different, translate different queries and endpoints, and then generate the code that you would need to use that in your programming workflow. Let's see if there is. Okay. Just what we went through just now. Okay, so again, what we just had was we came back, we still have this JSON blob. And I showed you earlier how you can use that from JSON, and from JSON will try to help you out a little bit by doing what it thinks is right. But there are also what are called API clients, and API clients, there's a lot an API client because it's the thing using the APIs to fill up the pages and etc. But here I'm saying API clients as in a package or a library that is designed to make it easier for you to use these data sets. And if you look at, for example, at ROpenSci, they've got, they've got tons of packages, but they've got a whole set data access, and these data access packages are designed specifically for very popular sources of data. Most of them are, wrapping up a bunch of interactions with the backend APIs or the backend databases. And it handles things like returning a table that you can use in an analysis. And it also handles things like, paging. It makes it so that you don't have to pull down, 50 pages and put them together. It'll automatically do that if you ask it to. So I just wanted to point out that there's a huge number of these packages, including some that our very own myself and Eric put together. So there's one called traits that you can get trait data from a number of different databases, and then one that Eric put together called WebChem, which accesses a whole, a large number of different databases. You can see here's a list. You can get data about chemicals from using this package. So, and if I don't search, so you can see there's 106 of these. Yesterday there was 108. Okay, so it's even easier if a client exists. So there's the RGBIF one, so you could do what I've just done, hit a lot of the different endpoints in that database and get information about species and to use in your analysis. Okay, so just in summary, because I've gone through so many of these tools, we looked at the browser, how you can get that, get the text back as a page, curl, which works at the terminal, Postman, R and Python have their libraries that effectively translate what Postman and curl were doing, but into those languages. And then you have these clients, which are very specific to a particular API and data set. So on the right, it goes from more flexible. I think pretty much putting together a URL from scratch is the most flexible, so that these all really count. And this is pretty flexible. And then these are, this one is easier to use, designed to make it easier to use. So there's just so much more to APIs that I would be happy to tell you, but it is the foundations and kind of getting much more into the guts. So there's like telling you more about the theory. There's also telling you more about, as you saw, the documentation, or how to interpret the documentation. And really, each API that you get to, if there's not a particular package, it's going to more or less be bespoke, and you have to read through the instructions, that documentation, to see which input, which endpoints are available, and what you get from them, and how, what parameters they support. So I'm going to go through a few, just a few other things, just to let you know what's there, primarily. So one thing I wanted to mention is the fact that, most of what we've been talking about are you could call them RESTful Web APIs. I want you to be aware, because you will hear that very frequently. It stands for representational state transfer, and you read all about it in Fielding's thesis or Wikipedia. But the important properties, a number of them that we've gone on, looked at. One is the idea of having a client and a server. So you have like the data provider as a server, and you have the client, and API is a layer in between them. And the layeredness is this layer of abstraction. Another important property is statelessness, which means that you call the API and it returns a result, and then if you call it again, it has no idea that you've already called it before. So multiple calls don't do anything to change what subsequent calls would be. That's my understanding of statelessness. There's also a whole number of things that, we'll look at methods that we didn't cover. So what we have really focused on is this idea of getting data from an API. But there's a number of different methods. There's four that are most common that you may hear about. You get them, you can put, if you wanted to create a record. So if you open up your phone and you add data, like if you use iNaturalist, you want to record you observed a puma, you happen to catch a picture of it, you can add it to iNaturalist. Behind the scenes, it's going to create a record. It's going to put that. If you later edit it, it will update that using Post. And you can also delete the record. So, and these are just the kind of the four canonical ones. There's a number of other different, verbs that can be used. So these are all verbs, and then the API endpoints, like species, occurrences, those are all subjects. So you can get a species, for example. So that's how you can think about what's happening behind the scenes. Oh yeah, I just had this arrow in order to say that this is the one that we really focused on, getting some data. The other thing that happens is, this can show up in your website, but it will often be a response in an API call. And I wanted to kind of show that there's a method to this. So it's not just that you got a 501, 502, 504 error, but something has actually happened. And 200 means that things are great. Redirection, it doesn't matter. It means like you pointed at one URL, it went to another one. That's like not really, that doesn't affect the data that you're collecting. But two important things. One is if you get back 400 series errors, that's usually your fault. I mean, it's not your fault, but it's something that you could change in order to make it work. And then if it's a 500 series, and it's on the provider's side. So these are your standard codes that they get returned. I also wanted to point out, I think I kind of glossed over this, but wanted to make sure it's clear that there are some limitations of getting and sharing data through APIs. So one is that there's no guarantee that the data will be the same every time you get it. And indeed, it's often a feature, as in the case with, if I was querying data from, weather data, excuse me, earthquake data, satellite data, those things are all designed to be updated every day. And that's why API is great, because every day I can go back to the API and I can say, give me today's information. But if you were to, it doesn't really work for reproducible research, because if you have your analysis and then somebody else reproduces it in 5 or 10 years, well, they'll be lucky if the API still exists and returns data in the same format, even though it should. But even if it comes back in the same format, it will be different data. You can cite the date of access, so that the common thing, no matter how you get information off of the web, is you say accessed on the date that you accessed it, and then you can archive the raw response, so that when people want to reproduce it, they skip the API call itself and they read in the this JSON file. Another thing I wanted to point out is that if we think back to the way that those, let's see if we can just look at one of these API calls. Let me see. Okay, so if we look at this again. Okay, so on one hand, it's very verbose. It's much more verbose than a CSV file would be, because a CSV file would have or a table would have a column, and it would say the name key once, and then each row would have a different key, and same thing for each of these values. So we can come through each record would become a row, and so they many more characters. If to get the same amount of data, you get many more characters. However, this is not a concern for data size, because JSON compresses very easily. There's very smart computers working behind the scenes very hard to reduce the amount of data volume that's being transmitted. That said, so it'll say, like, it'll know inside its head somehow magically that key, it doesn't have to read every single time, compresses it, sends it over the internet, and then when you collect it, it uncompresses it, and that's much more efficient. But at some point you can have a huge amount of data, especially when you're dealing with with satellites, etc., and sending it through through this protocol, HTTP, HTTPS, it can become well, it can take a good bit of time. You could see when I called it the command line, it was like timing it. It could take minutes. It can take even longer than that, and often an API provider will limit the amount of time that they'll allow that connection to be open. So it might be 10 seconds, it might be 60 seconds. It depends. That's why there's this paging. So you have multiple calls to get multiple pages, and that helps to. It'll still take a long time, but at least that server doesn't have to keep the connection open for minutes or hours. And with that, I'll open for questions.
Thanks, David. This is really good. Quick question, and it's going to be about the ASMAT API, I bet. And looking at this last issue you raised with, the data volume that you're pulling from a particular database, what are some strategies? You mentioned this, multiple pages. What are some strategies on how to think about that? In the case of the ASMAT database, is this just where, in order to get around a timeout issue, Is it where we just try to chunk the data up into smaller pieces and move it that way? Is that really the kind of the best practice at this point for something like that?
Yeah, I mean, that would be paging effectively. So chunk has different, uses. But yeah, putting it into different pages would be, I mean, to my knowledge, the best practice, the way that it's. That said, I think that it's, the ASMET data that I've downloaded, you're in the megabytes size range, right? Like, especially if you're looking at one site or, one season or 1 year, it won't be that that big. Yeah, I don't know that if you'll hit that limit.
Oh, that's a good point. Maybe it's on the Shiny app end where, I don't know, something's going on where it times out. And I know we've talked about this particular instance, but okay, yeah, I'm trying to think of ways to speed up the loading of the app. And if you change a parameter and have to update whatever numbers are on the screen, how to make that happen more efficiently. So but this is a good start. So thank you.
Yeah, and I'll also throw in, so I'd be happy to look at that with you. There's tools called profiling, so you can actually run the web app. You can see like which step is taking the most amount of time. But in the case of pulling data over, is what's called caching. And in fact, I mean, I found it, practical sometimes just to have like a file that maybe I'll update every once in a while, but effectively, I don't even, like if I have a web interface with a lot of data that I want to display, I just keep it stored locally. And maybe every once in a while, I'll go in and I'll check like what's the newest record. And if it's, if there's newer records, I'll pull them back. But if there aren't, then you just keep that same file there.
Okay, that's another good point. All right. Well, thanks again.
Mm-hmm. Yeah, you're welcome.
Hi there. I had a quick question, and this might be sort of something you would answer in like the part 2 of this, but I find the hardest thing for API usage for me is supplying headers in the correct way, or sort of parsing examples where they only give you the HTTP version of it. And so my example will be, I think I have it copied. No, not that, but Google Drive's API is just full of these lines of examples that I often feel like they think are simple and they're not. And so my question for you is, when you were learning this stuff and you were putting in your time and figuring things out, what were your breakthrough moments related to understanding how to supply headers in your requests to APIs?
Sorry, I'm laughing because it's I haven't had any breakthrough moments. I've except to reuse templates or to examples effectively in them. So yeah, it varies by API. So yeah.
Gotcha. Yeah.
Sorry.
No worries. Thanks.
Yeah. And I will say I've noticed that there's a number of programmers here who probably have more hands-on experience with APIs, and I welcome them to speak up if you have. I do.
I guess I have another question that
Okay.
you might have more to say about. So I do a lot of web viz, and often when I'm working with APIs, I run into the cross-origin restriction or CORS. Do you have workarounds for that kind of thing?
No, I haven't run into that. Can you say a little bit more about what it is?
Sure. I guess in theory, it exists to make it so that your loading of a web page is not allowed to like gain access from other web pages that are also open in that browser. So like it's to prevent JavaScript from one page reading contents from another page that it shouldn't have access to. But to be perfectly honest, the subject it's more complicated than that. And I don't always understand the extent of the security precautions that they're helping to avoid, or the breaches they're helping to avoid. But I know that a lot of times if I'm doing something like writing a program and it's supposed to allow a user using a web page to get data from somewhere else, then the use of the API from JavaScript will get blocked because of this thing called the CORS restriction, and that. So I was just going to bring that up and see if anyone had suggestions that they like. Also, I will cede the space to other people with other questions.
Yeah, and I apologize. I can't answer that.
No worries.
Yeah.
They're pretty esoteric, I guess. All right. Thank you for your talk.
Yeah, you're welcome. And I mean, there's a lot of this that is, wouldn't be as esoteric to a web developer, but is to scientists. So I've, in practice and, for this lesson have primarily focused on and used, kind of the types of things that I've shown, which is pulling back JSON from the internet. Let's see. Okay, and I'll open it up, continue to open it up for I'll also just continue and say, a little bit more about our group. So we're here to support data science across the College of Ag and Life Sciences and the Experiment Station, all throughout Alvacy. There are a number of ways in which we do that. You can come learn more about us on our website. We do have drop-in hours every Tuesday from 9 to 10 a.m. And we also have office hours by appointment. So if you go to the people page, you can find us, schedule an appointment. We do workshops like this by request. So please send topics. I appreciate that that Kamel sent me one, which is more hands-on with the audience. And that's always like, haven't found the right balance. But I know it's useful to provide hands-on. It's just a matter of getting through material, etc. But yeah, so by request, I'm happy to do something, redo this with more hands-on work, or work, come to drop-in hours and we can explore an API, solve a particular problem. And the problems we have, the ability to, if you've got a research problem, you want some support from our data science group, we've got, scientists, statisticians, developers, software engineer who can help to engage with you and kind of move from where you currently are to something more advanced. So that's internally funded through our grants to support research across the country. And you can find, you can look at our website, you can read it through the email. And with that, one last call for questions. Otherwise, I'll wrap it up.
You have one in the chat, David.
Oh, okay. Oh, have I used the Fiddler web debugging app? I have not, but would you like to say anything about it? Or watch me Google it?
Well, no, I was going back to Jeremy's question. I use it to so you can see the latency between requests, and you can track down, like you said, where the requests are getting hung up, to see if it's the server side or certain aspects on the server end or your computer or what. Anyway, I was just curious if you had used Fiddler.
No, I haven't, but I think, I mean, there is some amount of profiling type of work that happens over so I don't know, I'm not a regular user of the developer tools. I just find them handy. But but there was some place where there was this right here. I don't know if this is what you're talking about. It'll load up. It'll show you how long each step is taking. I think, again, I'm not that familiar with this, but is that different than the Fiddler?
The Fiddler shows you each of the calls and the puts and gets, and it shows you the latency on each one as it goes through the process. It's really
Okay.
we use it for connecting to ArcGIS Online
Uh-huh.
and looking at the different calls back and forth to the server and find out what process is taking time. And I was trying to get back to what Jeremy was talking about, the timeout, that maybe you could, something like this. I mean, I'm sure there's stuff like it, but okay,
Yeah.
that's all.
Okay, yeah, no,
would-
thanks for pointing that out. That looks useful. I'll probably fiddle around.
Okay,
Let's see, I got a few more messages. Okay. Awesome. You're welcome. I'm glad that it's useful. And with that, I'll stop the recording, and thanks everyone for coming.